With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's start with the question, and the question says that let S is equals to P belongs to R such that fx is equals to x minus pi mod x minus pi into e to the power mod x minus 1 into sine mod x is not differentiable at t. So is not differentiable at t. Then the set S is equal to, the options are first option 5, second option set with the element 0, third option a set with the element pi, and fourth option is a set with element 0 comma pi. Now what have been given is given fx is equals to mod of x minus pi into e to the power mod x minus 1 into sine mod x. So basically it is a multiplication of three functions. So we will find out that at what values does fx become 0. So if we put x as pi, so it becomes 0 because this function term will become 0 and all other terms are in multiplication, so the whole function fx will become 0. And if we put 0, because sine 0 is 0, then also this fx will become 0, or e to the power 0 minus 1, which is also 1 minus 1, will become 0. So again the function will become 0. So these are the critical points. These are known as the critical points. So the critical points are 0 comma pi. Now we have to check the differentiability at these 2 points. So we are going to check the differentiability at these 2 points. So at first we will see at x is equals to pi. At x is equals to pi, fx is equals to x minus pi e to the power x minus 1 into sine x. So f of pi is equals to 0. Now we have to check the differentiability at the LHL and the RHL. So the LHD, or the left hand differentiability, will be checked at f dash pi minus h. Why? Because if there's a number line, this is point pi, then just right hand side we will have pi plus h, and on the left hand side we will have pi minus h. So if we have to check the differentiability at point pi, so LHD will be f dash pi minus h is equals to limit h tends to 0 f of pi minus h minus f of pi upon h. So we are going to solve this. Now limit h tends to 0 pi minus h minus pi into e to the power pi minus h minus 1 into sine pi minus h whole upon h. So this pi goes off and we get limit h tends to 0 minus h into e to the power pi minus h minus 1 into sine pi minus h. Sine 180 degree minus theta is equals to sine theta, because it is in the second quadrant, and in the second quadrant sine is positive. So this will be equal to sine h, and this whole upon h. Now h goes off from here. So we are left with limit h tends to 0 minus e to the power pi minus h minus 1 into sine h. Okay, now we put the value of limit h tends to 0. So f dash pi minus h becomes 0 only, because because limit h tends to 0 minus e to the power pi minus 1 into sine of 0. So sine 0 is 0 only. So f dash pi minus h is 0. Now we will calculate the RHD. So for RHD, we have f dash pi plus h. F dash pi plus h. Now this will be equal to limit h tends to 0 f of pi plus h minus f of pi whole upon h. Now this is limit h tends to 0 pi plus h minus pi e to the power pi plus h minus 1 into sine pi plus h minus 0 because f of pi is 0. Note that here also minus this f of pi will be 0. So I did not mention it, but this is going to be 0 only. So it doesn't make a difference basically. Now here this will be equal to upon h, whole upon h. So again, when we simplify this, this will be h over here. So this h goes off and we are left with everything here goes off and we are left with limit h tends to 0. Now sine pi plus h is minus sine h because it is in the third quadrant. E to the power pi plus h minus 1 into sine h. Now again, if we put the value of h as 0, we get 0. So RHD, that is f dash pi plus h, is also equal to 0. Now here, therefore, at x is equals to pi, LHD is equals to RHD. Or we can also say that the function is differentiable at x is equals to pi. Now we will check it, the differentiability at x is equals to 0. Now at x is equals to 0. So firstly the fx is mod of x minus pi e to the power mod x minus 1 into sine mod x. So x minus pi e to the power x minus 1 into sine x. So when we put x is equals to 0, we get 0. So f0 is equals to 0. Now calculating the LHD, we will calculate it at f dash 0 minus h. So this will give us limit h tends to 0 f of 0 minus h minus f of 0 upon h. So limit h tends to 0, 0 minus h minus pi into e to the power 0 minus h minus 1 into sine of minus h minus 0 whole upon h. So we get limit h tends to 0, taking the minus sign common from here, and as well as sine of minus h is equal to minus of sine h. So we get h plus pi into e to the power minus h minus 1 into sine h upon h. Now this sine h upon h, limit h tends to 0, sin h upon h is equals to 1. So this will be equal to 1. Now f dash 0 minus h will be equal to 0 plus pi into 1 minus 1 into 1, which will be equal to 0 only. So f dash 0 minus h is equals to 0, or LHD is equals to 0. Now moving on to the RHD. F dash 0 plus h is equals to limit h tends to 0, f of 0 plus h minus f0 upon h. Now this will be equal to limit h tends to 0, h plus pi into e to the power h minus 1 into sin h upon h. Will be a minus 0 also. So we all know that this sin h by h is again equal to 1. So sin h by h, we can put it as a 1. This value, this is equal to 1. So f dash 0 plus h is equals to 0 plus pi into 1 minus 1 into 1, which is equal to 0. So RHD is also equal to 0. So we can write LHD is equals to RHD at x is equals to 0 also. So therefore the function is differentiable at all points in R, because we had to check for all real numbers in R. Okay, so basically there is no point at which the function is not differentiable. So it is differentiable at all points in R. So basically the set will be phi. The set will be equal to phi because it is differentiable at all points. So option 1 is the correct option. So we can say that therefore option 1 is our answer, which is phi. So this is it. I hope you get the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.